This lesson is for FST, Lesson 2.5 on exponential models. A quick review for students on the exponential model itself. Usually looks like y equals ab to the x. The a is the starting value and the b is the growth factor. Growth factor could be greater than 1 if it's growth or less than 1 if it's decay. Students' goal is to always find the a and the b value. X and y should remain as letters in your final result. So when you're finding a model, your job is to find a and b. So we're going to look at how to find an exponential model by hand first. Keep in mind that you will need 2 coordinates or 2 pieces of data in order to get that accomplished. So we're going to use this example to start. Population of a certain cell type was observed to be 100 on the second day of an experiment and 2,500 3 days later. Assuming the growth is exponential, find the number of cells present initially and the number of cells expected on the 7th day. So right away, you're going to create a system of equations. Keep in mind that it's a really good practice to put the higher exponent on top. A system of equations, remember, is 2 equations put together by 2 or more equations put together by a bracket. If students eliminate the bracket and forget about that portion, it's not a big deal. Mostly what I care about is that students are writing their equations. The very first piece of information they give you is 100 cells on the second day. So we've got 2 options here. Either we've got 2 cells creating 2 days creating 100 cells, or 100 cells creating 2 days. So it's important that students kind of talk through the relationship between the 2 numbers and see which one makes more sense for the experiment. Typically the time is your x. So when you look at your equation, typically you raise to the time or the x value. So typically the time will be x and the outcome or the number of things you're working with or looking at is your dependent variable. This is the one that's going to make the most sense here. That one doesn't. So that's going to tell us then that time is x and the number of cells is the y. So then we need our other set of data. Be careful here. There's 2,500 3 days later. Common mistake there is for kids to say 3, 2,500. Be careful because it's 3 days later. It's actually 2,500. Write it over here. 2,505. Because 3 days later after the first 2, that's 5 days later. So those are our 2 pieces of data. The one that's the higher set of numbers is the one I want to work with first. So remember that these coordinates are simply x, comma, y. So I'm going to start with the y value. And a and b I don't know, and it's being raised to the x in this case, which is a 5. Leave a little bit of room and do your other coordinate right underneath it. So again, start with the y value. A and b we don't know, and we're raising it to the 2. So we've created a system of equations. Technically there should be a bracket to the left, but we're not going to worry about that for now. Step 2 is to divide those 2 equations vertically. The reason for that is there's 2 variables currently, and we can't solve when there's 2 variables. So what happens when we divide is that notice that the a's will cancel. A divided by itself is simply a 1, so that eliminates one of our variables. And that's a good thing. The a should cancel out, and we got that to happen. Now we're going to divide vertically. It's very important that students remember to do the top number divided by the bottom. 2,500 divided by 100 I can do very easily in my head. If these weren't easily done in my head, I would just grab my calculator and divide. Keep in mind that you need to line things up vertically, so keep everything kind of neatly in line here. For the b values, you can simply remember to subtract the exponents. If you can't remember that rule, just write out what you have. We have 5 b's on the top, we have 2 b's on the bottom, and then keeping in mind that b divided by b is 1, we end up with 2 sets of b's that are going to cancel, leaving us 3 b's on the top. So that's going to turn into b cubed. Again, we could have gotten that answer simply by subtracting the exponents. And that's what it says in our directions. Subtract the exponents for the b's. Now we're going to solve for b. To get the b alone, you can do a cube root of both sides. However, it's better for students to start getting into the practice of using a reciprocal power to get the b alone. You won't always have a cubic that you'll be eliminating. Sometimes you'll be working with numbers like 24 or maybe even a decimal. And so to get rid of that, you don't always have a root available. So it's better to get into the habit of raising to the reciprocal power. So 3 and the 1/3, those get multiplied together. 3 times its reciprocal makes 1, so we get b to the first, which is what we're looking for. 25 to the 1/3, I'd type that in on my calculator. I will have to round that off, so we end up with about 2.92 here. Pay attention to what they want you to round to. This one doesn't say, so we're just going to round to whatever we'd like. Typically 2 or 3 decimal places is a good rule of thumb. Now we're going to plug B back in to solve for A. Keep in mind that you can plug it back into either of the 2 original equations. Typically I lead students towards using the bottom one, because the bottom one typically has lower numbers. Lower numbers tend to be easier for students to manage and are less places for kids to make mistakes. So I'm going to plug in 2.92 for B and I'm going to calculate. So my equation is 100, A I don't know, the B is what I just got, 2.92, and I'm going to square that. Keep in mind that this 2.92 that you had on your calculator is still potentially there, so when you square it, you can get a more accurate answer if you don't actually type in 2.92. So type in or use your previous B value, square it, and now to get that alone, we would divide on both sides by that value. So we're going to divide by 2.92 squared, and when you do that, you get 11.7. So that's your A value. So now assemble all the parts, the A and the B, and your X and Y go back to being variables. So your final answer then is Y equals the 11.7 that I just got for A, the 2.92 that I got for B, raised to the X. So that's my model. I found A, I found B. Next up, we're going to do a half-life problem. The procedure for half-life is, oh, and you know what, we did not finish the question, my bad. And so assume the growth is exponential, find the number of cells present initially. So the number of cells present initially was 11.7, or you could round that up to about 12. And the number of cells expected on the 7th day, you would simply type in a power of 7 and calculate. Let's go ahead and do a half-life problem. The procedure for half-life is clearly much shorter than the procedure we just did. When you're doing half-life, you're simply going to solve b to the time equals a half, and solve that for b by using a reciprocal power. Then we're going to use the a that's given, and we'll have our equation. So a certain substance has a half-life of 24 years. So we're going to say b to the 24 equals a half. To solve that, you use a reciprocal power to get the b alone. So I'm going to raise to the 1/24th power. When you type that in on your calculator, you end up with about 0.97. Again, pay attention to what they say to round to, because that will make a difference in your answer. So now they tell you that the A value is 80. Sample has 80 grams present initially, so that's A. 0.97 is the B I just found, and I'm going to raise that to the X. So there's my model. How much will remain in 50 years? All you would do there is fill in 50 for X. So you'll actually go ahead and type in 80 times 0.97 to the 50th. And you get about 17.4 grams. And the last answer here, when will only 5 grams remain? For that one, you're filling in 5 for Y. We don't know the X, or we don't know the time. So we're trying to solve that now for X. So the first thing you would do is divide by 80 on both sides. And when you do that, you get a new number here. On the other side, you'll have 0.97 to the X. At this point, students will need to either use logs if they remember how to do them. Put logs on both sides, and that moves the X to the front. Otherwise, you'll have to use trial and error to solve for the X. So you'll have to just simply do guess and check. Lastly, I want to talk to students about how to do exponential regression on the calculator. So you'll type your data into a spreadsheet in 2 columns, making sure that X is in column A and the Y's are in column B. Highlight both columns. On the Inspires, you'll have to use the Shift button to help you with that. And then you choose Menu Statistics, Stat Calculations, and Exponential Regression. So I'll demonstrate that here in one moment. So here I have my calculator with the data filled in from our first example, the 2 100 and the 5 2500. So I'm just using that as easy data to work with. Arrow all the way up to highlight one of the columns, hit your Shift key and then either right or left to highlight the other column. Then you just simply choose Menu, Statistics, stat calculations, and then you just scroll down for exponential regression. If you highlighted properly, your A's were your X column and your B's were your Y column. Just tab down to OK, and it'll give you an A value and a B value. So then we simply just copy that down. So we got 11.7 and about 2.92, which is about what we got when we did it by hand.